Hello and welcome back to another video of Leetcode solutions. In this video, we'll be solving this question reverse integer. So this question is as it sounds. We need to reverse an integer, meaning if we have 1 to 3, we return 3 to 1. Easy? Right. No, the question has some constraints which will make it harder, thus making it a medium difficulty problem. Let's mention an easy solution first. We can simply convert the integer to a string, reverse it, and then cast it again to an integer. This would be fine if the question did not allow for negative numbers, which will make us here require some extra steps. But the more challenging thing is that the environment works within integer range only, and this solution causes problems with it. Let's mention a solution which can be tailored to work within the constraints. So we have here an integer x and an output named r for reverse. All we need to do is take a digit from the right of x, push it to the right, and push r to the left, and add the digit to it. Here the 0 disappears since a leading 0 has no importance. We repeat that for the rest of the digits until we get the answer. But how is that done? To take the digit in x, we use the modulus operator. To shift right, we divide by 10. To shift r to the left, we multiply by 10 and then add the digit. And that is repeated over and over until x reaches 0. Until now, that's easy. So let's implement this part. So like we explained before, we initialize r with 0. Then while x is more than 0, we shift r to the left with multiplying by 10. We will get the last digit in x and add it to r, and then shift x to the right with the division by 10. And finally, return r. Now this approach doesn't work with negative numbers, especially since the modulus in Python does not give the expected answer. You would expect that if you take the most right digit here, it would give you -3. But instead it gives 7, which is -3 plus 10, giving the first positive output. How can we tackle that? We already know how to do a positive number, so we simply remove the negative sign and do the same steps as before, and then return the sign again. So let's add this part to the code. We add a boolean called neg, which will be true if x is less than 0 and false otherwise. And since we want to make sure that x is positive in any case, we can just use the absolute operator. And finally, multiply r by -1 if the number was negative and return it as positive if otherwise. And until now, this seems fine and passes all the tests. But in the question, it was mentioned that we should assume that we are working in an environment that allows integers only, which are within this range. If the result is outside these ranges, we should return 0. Since our solution already converts to positive numbers, then we can deal with this number only for now. In our code, we can always check if r is below the max bound divided by 10. If it gets over it, whatever digits we put to the right will make r get out of range. So here we can safely return 0. But what if we have a number that will get this exact number, which is the max bound divided by 10, and the first digit of it is 8 or 9? That means that our inverted number will be out of bound too. But let's look at the max bound. It starts with a 2. This means that the input will be out of bound for this case to happen, which is impossible as the input also has to be an integer within the ranges that was specified before. This can make us very sure that the numbers 8 and 9 can never occur. Only the numbers 0, 1, and 2. Actually, if we look at this number, even 2 cannot occur, since again x will be out of range. So only 0 and 1 here can occur, which makes this configuration safe. If you try that on the negative numbers too, it will give the same result. Let's add this final part to the code. We define the max range divided by 10 as a variable called max positive, as we discussed before, and we check if r ever passes this number, then we return 0. Let's test this one more time. Seems fine. Let's submit. Perfect. Put into consideration, the better running solutions are ignoring the assumption of only integer range, which removes parts of the code which make it faster. That was it for today. See you in the next one.